do we break the tie between A and C? We go to rule 2, which is what? The amount of formal charges. And we see C has 0 formal charges and A has what? 2? And so that would make that the most between that. Now we stop. We don't need to look at rule 3 or rule 4 at all. We're done. And so that is definitely correct. Nice work. So what is the hybridization state of that oxygen atom, class?
SP3. Oh, wait, no. SP2.
What is it?
SP2?
SP2. Because we have one of those lone pairs is what? Delocalized. It can resonate in. You can draw a resonance structure. So let's give you guys a few minutes. What resonance structures have you come up with? So I've seen some of you guys move the pi bond. You could move the pi electrons onto the oxygen. And so we could have something that looks like this. Okay, that's a valid resonance structure. And then from there, what could we do? We could take those pi electrons and move them right there if we wanted to. And then what am I missing on that resonance structure in orange? Right? You have to reevaluate every atom that has moved electrons, because I moved electrons for that atom and that atom and that atom when I went from purple to orange. And so now I need to reevaluate. What's the formal charge of that carbon, and that carbon? And the first two on the very top are going to be neutral. And then the one in the bottom left corner is going to be a +1, because how many hydrogens are on there? Only one hydrogen. So if we draw our one hydrogen, we can see that that carbon atom only has 3 groups to it. So there's only 6 electrons around it. Could we draw another resonance structure? Yeah, we could take this guy. We could take that lone pair, bring it down. If I bring that down, I need to break this bond right there, or I'd form a Texas carbon. And so I could have put it like right here and just stick it onto the carbon. And so now we would have something that looks like this. Now we have to evaluate what's the formal charges now. That's negative, and that's positive. Let's draw another resonance structure. Wait, what else have we missed? That's positive, right? What's the overall charge of this guy? 2 positives, 2 negatives, so it's 0. Formal charge on this guy, 0. All of the resonance structures, the overall formal charge adds up to 0. Could we draw another resonance structure from this guy? We could bring those down and form the double bond. Okay, something like that. So we can just keep going and going and going, as long as we're not violating any rules about octets or Texas carbons and things like that. So the question that students often ask is, well, when do I know I'm done? You really don't. Well, okay. You know you're done when you keep replicating the same resonance structures over and over again. Once you find duplicates, then you're done. But if you can keep going and there's no duplication of these resonance structures, then you just keep going. So on the exam, I could give you a molecule that has 10 to 15 resonance structures, but I wouldn't say draw all 15. I'd say draw, let's say, 8 of them. Okay? So there's not going to be that much stress, or so much stress on you guys at figuring out all of them. Okay?